So I think these have been in the background, but Colin, if you'd like to expand a little bit on some of the unique requirements for AV distribution in healthcare, because clearly it's not a vertical or not a market or not a domain that is exactly like broadcast or exactly like any other of the ProAV workspaces. What can you draw out from what you know in healthcare?
Yeah, I mean, I think the first thing to really remember is that, whilst, I mean, kids these days can watch things on iPads and small screens and fuzzy screens and, highly compressed, delayed images and pixelation and all that kind of stuff. There's a fairly low bar for your average consumer of content, but surgeons really are quite rightly very, very fussy about the imaging quality. And so I would say that, it's even more so than, maybe even broadcast specifications, where they're looking for, super high quality images. And so for me, there's the surgeons, as I say, if you want empirical testers of video equipment, a surgeon would be a good place to go, in my opinion. But there's some non-negotiables regarding AV. There must be no perceptible latency. I mean, there just cannot be a delay in seeing the instrument move once you've moved it. It's got to be instantaneous. You can't possibly operate efficiently, and the stress levels will rise if there's any kind of a delay between an action and observing the action. Obviously a long delay would make surgery totally impossible. And we know that, that an acceptable threshold for that is 1 or 2 frames of video. There should also be no perceptible video quality loss. I mean, there's a video signal will be can be corrupted by all sorts of factors. But one of the things that is fairly well benchmarked is that a signal to noise ratio of 45 decibels will create no observable degradation of the image quality. And that's about 1 part noise to 200 parts signal. So without those 2 main things, surgery becomes incredibly stressful and possibly impossible. Worth touching on maybe the compression myth. I know that there's people who talk about that, but and I've even seen it in tenders where they talk about no compression, which is kind of ridiculous, to be honest, and possibly disingenuous, because there's many other factors that could cause signal degradation, and unless you cover those, and I think Gareth mentioned one of them earlier on, EMI interference, electromagnetic interference is one. Particularly in a high electrical noise environment like an operating room. So you've got to look at the whole image chain and all of the possible factors in there. And there are some other requirements for healthcare video, surgical video. I mean, signal integrity. We know that it should faithfully reproduce the contrast, color, and geometry. You don't really want to have kind of distortion in there. And it has to be, particularly with 3D, you want a very natural depth of field. You don't want an artificial depth of field. You don't want things to appear longer or more distant than they really are. So true life 3D depth of field is an important thing, but signal and integrity essentially. And then we come on to patient safety. Our encoders, screens, camera sources are very close to the patient zone or the patient bubble. This equipment really should be MDR Class 1 approved. We have to take care, particularly the most important factor here is electric shock. So we have to prevent macro shocks or micro shocks. Although the human being can detect, or just about detect 500 microamps on the skin, it only takes 100 microamps across the heart to give you a fatal shock, ventricular fibrillation. The irony is that I don't know whether Edison knew this at the time or not, but 60 hertz is the perfect frequency to get electrocuted from. So why he picked 60 hertz is a bit of a mystery. But anyway, that's it. So at 60 hertz, you've got to be really careful with 100 microamps. And then, of course, we touch on data protection and cybersecurity. And IP systems are innately more secure. They have lots of security standards and protocols. and the IP signals are easier to encrypt and much more difficult to hack. So they're the kind of, I would say, the 5 main areas of what it is necessary to have for AV distribution in healthcare.
Yeah, and I think that you know, just to again put the SDVoE spin on this, clearly the latency, image quality are 2 things that we do, you know, make a lot of a noise around. But it's often overlooked, the signal integrity piece that you mentioned, the ability to use fiber-based systems that are much more immune to electrical noise and carrying electrical current, of course. But not only fiber systems, but based on very robust standards that have been around for years, that are well and truly road tested. You know, 10 gigabit Ethernet has been used in the data center industry for many, many years, running 24/7, you know, 365 days of the year. And the one that I think you mentioned, but again, is often not discussed as much, is the security piece. And I don't just mean the security of the data, but the ability to be able to set up a network such that an OR can share content within that room, but perhaps it doesn't share content outside there. But there are instances where you do wish to have, for example, inter-OR connectivity. And the software piece of SDVoE really allows that kind of segmentation, which can be very, very powerful and useful for creating, you know, specific domains, if you like, where content can or cannot be shared.
Yeah, I think we may even touch on some of those points in the next question. I think it's very valid points.